Hello everyone, hopefully you're doing well. In this video, we're going to continue with section 2.1, frequency distribution for organizing and summarizing data. I didn't want the previous video to be too long, so I cut it off and come back. If for some reasons you miss everything we did in the previous video when we introduced the frequency distribution for organizing and summarizing data. We talked about the key concepts we're planning on covering. We went over frequency distribution, the definitions of frequency distributions, relative frequency distribution, the different steps to go through on how to find the midpoint, the cumulative frequency, the relative frequency, and we went over a very simple examples where the class intervals were already given, the frequency was given, but they asked us to add in that table the midpoint, the class boundaries, the relative frequency, and cumulative frequency. In exercise number 2, what they ask us to do, and we will do it together, is list below are the first 50 Chicago commute times from data set 31. So what they ask us to do for this one is to construct a frequency distributions. Oh, okay, so because we need to construct a frequency distribution, the first thing I'm going to do is to make this one smaller because we need space for it. We're gonna try to put this table somewhere here because we need space. All right. If we have to do it somewhere else, that would be fine. I can even put it down here because we need more space for it. All right. So they ask us to use the class width. Remember, when you construct your class interval, we must have the class width. So what they ask us to do here, we talk about the 50 Chicago commute time, daily commute times in Chicago. So that's what we're going to focus on. If we construct that tables, daily commute time in Chicago. I try to make it like very simple because the first step is to construct that tables where in the first one would include the class intervals. So what they ask us to do, remember a class interval, each class interval has a lower class limit and an upper class limit. If you want, usually you go into this, you need to go into into the data set and identify the lowest number. That would be the minimum. So for us, the minimum in that data set is 4. You can go ahead also and identify the maximum. So the maximum, you can verify it. You see, we have 60. I believe 60 would be the maximum. So 60, is that 60 the maximum? Can we verify again? We have 60, everything is 6, 6, not 60. You can verify with me. If 60 is the maximum, oh, nope, 80 is the maximum. So maximum is 80. So we need to set our intervals in a way for including the first class interval and 80 include in the last class interval. So, but the good news is that they said the width, we don't need to look for the width because they said use class width 15. So we have the width equal to 15 and begin with lower class limit 0. So we know our first class limit would be 0. 0 plus 15, remember, is the difference between the two lower class limit, consecutive class limit, or upper class limit. So if we start with 15 here, then we ended with 14. 15 plus 15 give you 30, then it was 29. 30 plus 15 is 45. Then that one was, yep, that one was 44. So 45 plus 15 is 60. So meaning this one is 59. 60 plus 15 is 75. That means it's 74. 75 plus 15, that make it 90. And this one is 89. So I don't need to go 90. The reason why I don't need to go 90, I already see the maximum data in the data set, the maximum value, the largest value in the data set, including the access, which is 80. So I don't need to go a 90 to something. So at this point, you see how many you can identify the number of class interval here. So we have one, two, three, four, five, and six. Well, actually, what they want you to find is the frequency distribution. That means you need to count the number of data you see from 0 to 15. So we can go and try to do it in a way like you can identify them because for the first one, I see from 0 to 14, that's one, okay, that's two, that's three, okay, that's four, and that's five. So we know this one would be fine. Make sure you take time to count properly because your answer, you cannot mess up on this because if this one is incorrect, then your histogram, your graph would be incorrect. Now, how many data you can identify from 15 to 29? 15 to 29, remember this is one, two, three, four, five, six, seven, eight, nine, 10, 11, 12, 13, 14, 15, 16. So you see this is 16 here, which is good. And how many data from 30 to 44? We need to count the number of data from 30 to 44. 30, 44, we have 44. One, two, three, four, five, six, seven, eight, nine, 10, 11, 12, 13, 14. Yeah, so we find 14. Remember, you cross out, that's help you to go faster. How many data from 45 to 59? 45 to 59, 69 in it. One, two, three, four, five, six, seven, eight. Right? Is that it? You said 15. All right. So I believe that's it. That should be it, or do I miss one? Because when I did it before, I found 40. I found nine. 45. Do I count? Yeah, 45. I don't know how many 45 I count. It's hard to 59. 60 is not in it. Oh, there's another 45. That's nine. That's right. So 60 to 74. We can do 60 to 74. One, two, three, four, five. and 75 to 89 is only one. So this is it. This is our frequency distribution because a constructive frequency distribution use a class width of 15 minutes and begin with lower class limit of 0. Means do the data set amount appear to have a normal curve. Normal curve is usually you start with smaller number, in the middle you have some larger number, then it fall again to smaller number. So the data set, the data amount, do not appear to have a normal distribution. The distribution does not appear to be symmetric. I think if you try to see this, you have too many data close to the beginning because you have a feeling it's more screwed left, right? Screwed right, sorry, because we have more bigger data at the beginning, right? Because the frequency as preceding the maximum frequency of 16 are far outweighed by the frequency following a minimum. So that's an example. I'm hoping you can use this one to do more exercises. Remember, the best way to do it, I can leave you that one because, as I said, I do one examples and I let you do another one. But know that if you try to do it, this would be the same. What they ask you to do is list. What they do here is list below are the ages. So if you have ages, make sure that would be your class interval. So the first thing to do in that data set is always go and identify the minimum. The minimum data in that data set would be maybe it's in the 40s, right? I see 42, 42, I see 42, right? That's what's 42. I think 42 is the minimum. So we're gonna consider 42 as the minimum. And the maximum, we can verify what the maximum would be. The maximum would probably be how many in the 70s? Because I see already see a 70s. So I believe the maximum would be 70. So maximum would be 70. So that means we need to set up our class interval in a way that the minimum 42 is in the first class and the maximum 72. But the good news, they said President who took office as a result of an assassination or resignation are not included. The data are current as of this written. Use this age constructed frequency distribution. Use a class width of 5 and beginning with a lower limit, they said we need to start with 40. So if we start with 40, 40 plus 5 give you 45. So that means would be 44. 45 plus 5, 50, 49, 55, 54, 60, 59, 65, 64, 70, 69, and I can go 74 because remember the width, I add 5 for on each lower limit or on each upper limit. Two consecutive lower limit, you can find the width, or two consecutive upper limits. Now, what is the frequency? In the tables, if you look and find all the data, because for now, all they ask you to do is to find how many data in between 40 and 44, it's 1 and 2. So we have only two of them. And you can continue. As you do it, you would see it's 2, 7, 10, 10, 6, 3 and 1. So feel free to verify on your own. Remember the totals, always go with the totals if you want to continue with adding the midpoint, the relative frequency, the cumulative frequency in the same table. So do these data appears to be a normal distributions. The age do appear to have a normal distribution. Look at that. We start very slow and go with 10, then we go down again. So yes, it is. Next examples, as we have two of them. This one is a little bit different. Remember these three examples, we would use Excel to explain it to you. But that is very similar to the TV examples I use. Remember, I said, how many TV set per household. So you see here the maximum. What is the minimum and the maximum in that data set? Find the smallest number and the largest number. Yes, the smallest number in this data set, the smallest number is 0, and the largest number is 4. So all you need to do is to construct, because this at least below the F-scale intensity of recent tornadoes, recent tornadoes in the United States. Construct a frequency distribution. So we said, we said tornadoes, tornado, F-scale. F-scale, we're gonna set frequency. So we have 0, 1, 2, and 3, and 4. So all you need to do, identify the number of zeros you see here, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And how many ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 ones. And how many twos? 1, 2. Wow. And how many threes? 1, 2. And how many fours? I have only one four. So remember, this is the frequency. You can always add and make sure the total correspond to the number of data in the data set. For example, here, if you do this one, it would give you 40, 42, 44, 48. So make sure when you add all of this, it gives you exactly the same number of data, right? So when you add them up all together, it should give you exactly the same. Hopefully this help. And oh, sorry, it's only one. I put 4. It's only one because the total would be 45 in total as you add, you count all of them. The last examples, what they ask you to do, okay, the previous examples, as you can see, it's mostly quantitative data, right? So those are data. How many tornadoes? Tornadoes 1, 2, 3, 0 tornadoes, etc. You see this one also, we're talking about president ages, so those are numbers. The previous one also, we're talking about commute times, again, quantitative data. But the last one is about not quantitative data, but qualitative data, because it said use a given categorical data to construct a frequency distribution. So because in this case, we focus a lot in constructing frequency distributions. I'm hoping you can remember how to do it because it says natural births randomly select from 4 hospitals in New York State occurring in the days of the week. What are the days of the week? Days would be, please, if you remember the days of the week, it would be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So we have 1, 2, 3, 4, 5, 6, 7. Now, in that table, they would tells you the number of births per day of the week. So you remember the days. all you need to do is to count the number, or it's already given, because in this exercise, with these frequencies, all frequencies are given. Yes, they save us everything. So Monday, 52 birth, 66 in Tuesday, 72 Wednesday, 57 Thursday, 57 Friday, and 43 Saturday, and 53 on Sunday. So the best you can do here, those are the frequencies. Remember, those are the frequencies. But what they ask you to do, construct a relative frequency. Remember how to do relative frequency. How to do, because we went over one examples in the past, in the previous video. So how to find a relative frequency? First of all, you make sure you add up all these data together. So when you do, if I grab my calculator, I do 52 plus 66 plus 72 plus 57 plus 57 plus 43 plus 53. The totals is 400. Now, how to find the percentages? The same way I said at the beginning, if in the classroom there are 28 students, 17 of these students identify themselves as female, the percentage of females in this class is 17 divided by 28. So we can do the same. If you want to find the percentage of birth for Monday, you take the 52 and you divide it by 400. You take the 66, you divide it by 400. You take the 72, you divide it by 400, etc. Divide by 400. That's the total, right? So you divide by 400, 43, 400, 53, 400. Okay? So all we need to do is to take each of them, like 52 divided by 400. Oops. Divided by 400, that gives you 13%. Remember, we express it in decimal, but if you want to do it in percentages, multiply by 100, that make it 13%. If you take 66 divided by 400, that would give you 0.165. If you multiply by 100 with 16.5%, 72 divided by 400, 18.18 or 18% if you want to. 57 divided by 400, that's point 1425, so 14.25%. So remember, this one would be exactly the same because they are the same. That's 14.25%. And if you do 43 divided by 400, it would give you 0.1075, 10.75%, and 53 divided by 400, it gives you 0.1325, so 13.25%. All right. So hopefully that's helped. That will be the last exercise in section 2.1, frequency distribution for organizing and summarizing data. In a different video, we would come back, of course, to construct more graphs, especially histogram, using either relative frequency or frequency distribution. Let me know if you have any questions. I'll see you in a different video. Take care.